So now that we're finished with translations, we're going to start talking about reflections. Now, reflections are the second type of our rigid, that color's no good. There we go. Our rigid transformations. Okay. Now remember that rigid transformations change the location and or orientation of a shape on the coordinate plane. So translations and reflections are our first two types of transformation. There's only rigid transformations. There's only one more rigid one, which we'll discuss later. Now, orientation, remember, that means how a shape is positioned on the coordinate plane. So here, we talk about a triangle. It says I can have four different types of orientation. Peak pointing up, peak pointing down, peak pointing right, and peak pointing left. All right, for example, so what I mean by that, that's this peak pointing up. It could also be like this. That peak is pointing down. And then it could be like this. That peak pointing to the right. And it could also be like this. That peak pointing to the left. And that's what I mean by orientation, okay? Reflections will change location and how a shape is positioned or the orientation on the coordinate plane. It'll do both. Now, in this class, we only reflect shapes across the x-axis or the y-axis. Okay, I haven't said that in here, but that's the only two type of reflections we do. So reflecting a shape across the x-axis is horizontal. I'm sorry, this should be y-axis. Reflecting a shape across the y-axis is horizontal movement only. And that may seem weird because we talk about the y-axis, that's vertical movement if you move up and down on the y-axis, but we're talking about reflecting across the y-axis, and you'll see that in the examples here in a few minutes. Okay, now when we do a reflection across the y-axis, the y coordinates of the vertices will stay the same because again it's horizontal movement only, but the x coordinates will change their sign. So if it's a positive, it'll change to a negative. If it's a negative, it'll change to a positive. That's it. Now, if we reflect the shape across the x-axis, now that's vertical movement only. Okay? And in that case, the x coordinates of the vertices will stay the same, but the y coordinates will change their sign. That's it. That's the only two things we got to remember for reflections. And we're going to look at an example of each type. So here's a triangle. It says it has vertices located here, reflected across the y-axis. So let's graph this first. All right. So negative 4, 2. Here's the origin. So negative 4, 2. 1, 2, 3, 4. 1, 2. And this is A. B is at negative 4, negative 2. So it's going to be down here. This is B. And C is at negative 1, negative 2. All right. So this is our pre-image. And I know that because there are no prime marks on the vertices. Okay. So pre-image. Again, you don't have to put the P in there, but you may want to. Okay. Now, we know this is the x-axis. We know this is the y. So we're talking about across the y-axis, which means I'm going this way. I'm going to reflect it across. Okay. Now, to perform the reflection, so there's two ways to do this. All right. The easiest way is you're just going to count the number of spaces you are away from the y-axis for A, okay? You're going to count the number of spaces you are away from the y-axis, and then you're going to go that many on the other side. Again, we're counting, okay? So let's count. 1, 2, 3, 4, okay, to get to the y-axis. So if I reflect this, it's going to be 1, 2, 3, 4 to the other side. And this is A prime. And C is only one away, so it's going to be here, C prime. And again, you can count B is 3 to the left. Now, be careful here. Some people want to put B over here, but remember, you're reflecting it across. It's going to go all the way over here now. And you can count 1, 2, 3, 4, and then count another 1, 2, 3, 4. And this is your reflected triangle. This is the image. And we just reflected that triangle across the y-axis. And I hope you can see, and this is later on in the notes, that's what we did. We flipped, okay? We flipped this pre-image across the y-axis. Or you can think of a mirror image, okay, of the pre-image. The image is a mirror of the pre-image across whatever axis. That's it. That's all reflections are, is you're flipping a shape either over the y-axis or the x-axis. Okay. Now, if I was going to do it by the coordinates, I could say, well, that means A prime. I told you that it's horizontal movement only. That means all the y coordinates stay the same. So this is going to be a positive 4, 2 for A prime. B prime, because the x changes its sign, the y stays the same. B prime is going to be a positive 4, negative 2, and the y coordinates stay the same. And then C prime, change the x to 1, and the y stays the same. And you can see if this is right. If I go, pick a different color here. So if I just say, okay, 4, 2, 1, 2, 3, 4, 1, 2, you can see that that's in the right place. B is at 4, negative 2, 1, 2, 3, 4, 1, 2. Right here it is. C prime is supposed to be at 1, negative 2, and there it is. So you can see that either just by counting the number of spaces you are away from the y-axis, then it still works. Or if you do it by using the rule of changing for this reflection, changing the x coordinates, they're just their signs, and keeping the y coordinates the same, either way you get the same shape. You get the same reflection. And that's all it is. Let's look at a reflection across the x-axis. Okay. Now, once again, I'm going to graph this shape first. So 3, 2, 1, 2, 3, 1, 2, and that's D, 7, 2, 4, 5, 6, 7. That's E, 3, 7, which is way down here. That's F, and 7, 7 down here, which is G. Now, I picked this for a very specific reason. You're going to see. Oh, wait. No, I messed up. See, it happens to everybody. 3, 7 is up here. This is F. And 7, 7 is up here. This is G. Okay. So here we are with our rectangle. All right. Now it says to reflect across the x-axis. So once again, I'm going to show you both ways. So first, I'm going to do the counting method, okay? And you got to do each vertex. So D is 2 away. So again, this is the X and this is the Y. And it's vertical movement only in this case. It's going to flip over the X-axis. So D is 2 away, so D prime is going to be here. E is 2 away, so it's going to be here. F is 7 away, so I got to go 7 this way. So if you count 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7. So that's got to be F prime, and G prime is going to be right here. Rectangles and squares, anything like that, are a little bit easier than triangles, but triangles aren't incredibly difficult. And this is your reflected shape. This is the pre-image, and this is the image, and you're done. That's it. That's all reflections are. Now, again, if I decide to use the rule, I told you that for a flip or a reflection across the x-axis is vertical movement, which means the x-coordinates stay the same. You can see I didn't move it horizontally at all, but the y-coordinates will change their sign. So let's apply that rule. So for D prime, if I'm following the rule, looking at the coordinates, x stays the same, but y changes its sign from the original. And then E prime, x stays the same, y changes its sign. F prime, x stays the same, y changes its sign. And G prime, x stays the same, y changes its sign. And now I can check to see if those are the same coordinates as what I actually have on the graph. So 3, -2 would be from the origin, 1, 2, 3, 1, 2 down. And that is the right place. 7, -2. 1, 2, 3, 4, 5, 6, 7, 1, 2. 3, -7. Well, I know this is 3. 1, 2, 3, 4, 5, 6, 7. And then 7, -7. Hopefully we can deduce that this is 7, -7. So this works. So either way you decide to do it. For me, personally, the just the counting and flipping those points across the axes are easier than doing this. Okay. I don't have to keep track of positive and negatives. I can just look and count. Okay. But to each their own. So, and I've already said this, but now we're going to put it in our notes. It may help to think of reflections as mirror images of each other. We are simply flipping the shape over the indicated axis, either X or Y. The main thing is, and this is where students make their most mistakes, the key is to correctly identify which axis the reflection is being performed across. Because students get their X and Y axes mixed up. You've got to know that the x-axis is the horizontal axis and the y-axis is the vertical axis. If you get those confused, it's going to mess you up. So let's do one more. And that'll be it. Reflections are very, very easy. So here's a trapezoid. HIJK has vertices located at. So let's graph this. Already, okay. So negative 1, 3. Negative 1, 1, 2, 3. This is H. I is at 1, 3. So that's going to be here. Negative 4, negative 2. 1, 2, 3, 4, 1, 2. This is J. And then 4, negative 2. 1, 2, 3, 4, 1, 2. This is a trapezoid. Now, I picked this for a very specific reason. I want to show you something. We talked about this in translations, how sometimes uh, the pre-image and the image will overlap each other. It's the same thing here. So I'm going to write P for pre-image. This is why using the prime marks on your vertices for the image is so, so important. Because when they overlap each other, you need to know which one is which. So let me change pen colors here, like I've been doing. We'll go to blue again. It says reflect across the x-axis. And then it says give the coordinates of the vertices. And then make sure to label it correctly. So we got a couple things we got to do here. So first I'm going to do the reflection just by counting. So in other words, H is here. So H prime, 1, 2, 3, 1, 2 is going to be here. Which means I prime is going to be here. Again, if you need to do the counting, 1, 2, 3, 1, 2, 3. Again, this is the X, this is the Y. Now do J and K. J is 2 below the x-axis, so that means that the J prime is going to be 2 above. And the same thing for K. And I'm going to play connect the dots, and you can clearly see here that these two images, these two shapes, are they um, not connect. I can't think of the word, but they overlap. There we go. They overlap each other. That's why the prime marks are so important. Okay, please use those prime marks for your image. So you see, I have P in black for the pre-image, and I'm gonna put the I in blue over here for the image. Okay. Now, so I've reflected it. It says give the coordinates of the reflected shape. Well, you can either sit here and count, but in this case, I'm going to use the rule. So remember, we said if you reflect across the x-axis, and you can see here the x coordinates did not change. Okay, I only moved up and down. So h prime is going to be 1, 3. I'm sorry, 1, negative 3. The x coordinates stay the same. What did I do here? I did that completely wrong. Negative 1, negative 3. There we go. The x coordinate stays the same. The y coordinate changes its sign. And you can count negative 1, 1, 2, 3, negative 3. It's in the right spot. I prime, x coordinate stays the same. So 1, y coordinate changes its sign. J prime, x coordinate stays the same. Y coordinate changes its sign. K prime, x coordinate stays the same. Y coordinate changes its sign. We already verified H is in the right place. 1, negative 3 for I prime. 1, negative 3. J prime, negative 4, 2. 1, 2, 3, 4. 1, 2. K prime, 4, 2. 1, 2, 3, 4. 1, 2. So they're all in the right place. And guys, that is it for reflections. We're right at 20 minutes. There's nothing else to do. So I'll see you guys in class and we'll have an exercise to practice reflections.